Hello, welcome to lesson 14. In this lesson, I will be talking about the concept of guards. So guards make pattern matching even more powerful. I will tell you what is the guard, what is a guard sequence, what which expressions are legal as guards. These are the guard tests. I will also show some examples. So let me maybe start with the example to show you the anatomy of guards and how they can support you. So I will write simple factorial module. If you remember, during one of lessons, I said that I will show how I showed how the factorial looks like with three clauses, and I said that this can be written only in two clauses. So using guards, and I will do it for this in this example. So factorial looked like this. For 0, we have of course 1. For 1, we again have 1. And for n, we have n times factorial of n minus 1. So basically, whenever somebody wants to calculate factorial of 5, for example, it means he wants to calculate such expression. Okay, so this is what this recursion is doing. And here we have three clauses, right? For 0, for 1, and for n. Now, let me execute it from Erlang shell. For example, for 0, it's 1. For 1, it's 1. For 2, it's 2. For example, for 5, it's 100. For 100 is, yeah, this number quite large. So this is factorial, which I wrote using three clauses. Now I will rewrite this so that I'm using only two clauses using guards. So starting from the guard anatomy, so if you remember, we have some function and this function have head. It has 0 or more arguments, and they said that then the body goes, and the body which has some clause inside separated by semicolons, and then we can define the function. And today we'll learn about the new concept, which is optional expression, which we can write here when, and here we can write guard. So here it could be guard sequence, and it will look like this. For example, so this is the guard sequence, and the guard sequence is a single guard or series of guards separated by semicolons, and at least one of these needs to be true, so that this guard test will execute this body. There is also guard, which will look like this. These brackets here are only to indicate this is optional. I will show how does it look like in the code. And then we have separated by commas, and then all of this expression needs to be true, So guard 1, 2, and then all these guards needs to be true so that this body will be executed. Now this is also worth mentioning that guards always evaluate to true or to false atoms. Okay, so let's think how we could rewrite this factorial so that using guards we could reduce one of these clauses. So I will remove this thing, and here I will use right here the n argument, and here I will add the guard. In this case, I will write something like n is smaller than 2. So if you remember, we had factorial for 0, which was 1, and factorial for 1, which was 1. And here I removed one of these clauses and just kept this clause and said and added this guard n is smaller than 2. If this one evaluates to true, so n is smaller than 2, then it will go and evaluate this function and return 1. Otherwise, it will go here. So let's check how will it work. I compiled my factorial module, and now I can type some tests. Okay, for 0 it's 1, so it executed the guard was evaluated to true, which also we can say that evaluation succeeded. And here also evaluation of the guard succeeded, and here it will go to this generic, let's say, evaluation without guard. So then we are saying that the guard test has failed. So it returned false. So we can again return some values, and as you can see, this is it works. So as I mentioned, this guard will evaluate for 0 and 1. Okay, also for the negative numbers, but in this case we don't want to have negative numbers. We could somehow also handle it, but for simplicity I will keep it like this. So of course it will be evaluated to true, or evaluation succeeded, right? Or so this we can say, and here for things higher than 1, so 2 and above, this one would be evaluated, or let's say this one for values higher than 1, this one would evaluate to false, or the guard would failed. So this is the terminology which is used regarding guards. Okay, so this is how we could reduce amount of clauses using guard for this factorial. And now for the further explanation, I will create a new module, which I will call range. And this will be very artificial example, but let's say that I have some range function which is used for monitoring of the input numbers, and depends on the value of this number, it will return some string. So I will use this artificial example to show how the guards and guard sequences works. Also, what kind of things are legal and what kind of things are illegal in guards. So this will be module range, which will export only one function range with arity1. And here, let's say that this function takes value x. And Oh, sorry, I forgot about the guard. And here we have first guard. Um, first, let's say expression here will be is integer. So this is the check, of course, if the input x is integer. Next one, I want to check that x is greater than, let's say, 10. And the last check would be to say that the x must be greater than, smaller than 100. In this case, for this, yeah, I will just write something like is in range, something like this. And here I need to pass, of course, x. And for any other cases, of course, I could have more clauses with some guards, but here I will just have two, one with guard and second one without. And I will just write w is not in range. And here I also want to have new line, as well as here. And here, since this is clause, I need to have semicolon and not dot. Okay, so as you can see, this guard will test if the input x is integer, if this integer is greater than 10 and is smaller than 100. Now this is a guard, and basically all of this must be true because it's separated by comma. So this is the series of guards, and yeah, as I mentioned, this complete guard will be true only if all the guards are true, if all of these succeed. So let's see. Let me run the Erlang shell. Let me compile the range module. Okay, everything is fine. So I can type something like range. And the example of integer, which is smaller, let's see, now I want the guard to return false. I'll write 1 because it must be higher than 10 and smaller than 100. Okay, 1 is not in range. Let's see about 11. 11 is in range and 101 is not in range. As I mentioned, all of these expressions must return true. Then let's say what would happen if I return the value which is in the range, for example 11, but it will fail on the first test, which is integer. In this case, I'm passing float. Okay, and I get the information that 11.11 as a float is not in range because the first test is integer, has evaluated to false, therefore it was not succeed. The guard evaluation didn't succeed that, and this more generic clause was executed. Now, to demonstrate what's the difference between guard and guard sequence, I will slightly modify this code. And I will write a sequence, which guard sequence, which I will just replace the commas with semicolons. And now the definition of guard sequence is that it's a single guard or series of guards separated by semicolons, as I mentioned. And if such a series of guards is present, then at least one needs to evaluate to true, which means that if I will pass integer, but the value will be less than 10, it's still still this clause will be evaluated. The same here if I will pass float, for example, but one of these will be true, then again the first clause will be evaluated rather than second. Let's see how it will work. Now if you remember, 11 as a float was not valid. In this case it will say that it is in the range because it's greater than 10. It's no longer integer, but we are no longer have a guard but guard sequence. Therefore, at least one of that expressions was evaluated to true. Therefore, we got the first clause evaluated rather than second. Similarly for 101, because 101 is greater than 100, than 10, sorry, which means it is evaluated to true. So this is the example. Now let me maybe show you something. You're probably wondering if it is possible to create some, let's say, function is a, let's say, and in this function I will type something like x equals to a. Very simple function which checks if input x equals to string a. Let's see if it will work. Um, I didn't export this. Okay, so this function will return false if input is not equal to a, and it will return true in case of it is. Let's see if we can use it in the guard. So here I will, for example, say additionally is a x. So, and here I have guard sequence, so at least one of these must be true. So let's see how it will work out. I will try to compile this module to demonstrate what will happen now. Okay, I got the error in line 7. Call to local imported function is a is illegal in guard. So this is very, very important because we need to now talk about the things which are legal and which are illegal in guards. So basically guards cannot call user-defined functions because it must be ensured that there are no side effects in calling, um, in evaluating the expression in the guard. So expression in the guard cannot have side effects. They just must be side effect free, execute and terminate. So this is a very important thing so that you don't get confused while you're trying to write some custom function. And also when we are talking about the legal and illegal stuff in guards, let's have a look at the documentation to see what kind of things are legal and illegal for the guards. So for this purpose, I prepared this documentation. I opened this documentation, which is Erlang reference manual. To go here, you just need to go to erlang.org/docs, or when you're on the Erlang page, go to the documentation and then you can go to Erlang reference manual, user's guide. And once you're here, you can go to expressions, and here go to guard sequences. And in the section 826, there are things which are valid in the guard. So here it's listed, so the variables are valid. Constants like atoms, integers, floats, lists, tuples, records, binaries, and maps. Expressions that construct atoms, integer, floats, lists, tuples, records, binaries, and maps. Expressions that update a map. The record expression, which I will be talking about records in next videos, probably around lesson 18 or 17. Calls to beefs, but these are not the Erlang built-in functions, but these are the guard beefs. So these beefs are listed here. So this is very limited list. If you would go to beefs of Erlang, there is much more functions. But when you are looking at the guards beefs, you have only call to apps, absolute value of the number, bit size, byte size. I'll take the nth element of the tuple, get the float, head of the list, take the head of the list, take the length of the list, get the key from the map, get the map size, get the information about which node this is executed. This is similar, and the round of the number, ID of the current process, size of tuple of bit string or bit string, tail of the list, trunk number, and tuple size. So these are the beefs which are allowed. Other built-in functions are not allowed. And we have also, what else we have here? We have also type test beefs. So you've seen that I was using integer, is integer, with arity1 to check that the input argument is integer. We have also is atom, is binary, is bit string, is boolean, is float, is function, is integer, is list, is map, is number, is bit, port, record, reference, and tuple. So these are allowed guard tests. Now also it's allowed to pass the term, comparisons, arithmetic expressions, Boolean expressions, and short circuit expressions like and also or else. Maybe I could show some examples of this. So let me go back to here to Erlang show. I will close this thing. Clear. And okay, I will define, for example, min module, and I will have something like export min. I want to calculate the minimum of two values, and here I will have the min xy, and then the guard. If x is smaller than y, then x, and otherwise y. So this is the comparison expression. Term comparison, so-called term comparison. Okay, let's see how it will work. I think I have, of course, the min takes 2. The arity of this function is 2. Just to be safe, I will call everything my min. So this is my function. No, this wasn't the case. Sorry, I actually could keep it as a min, and I will keep the problem is that I defined here it as a dot, so it thought that this is the new function, other function, rather than clause of the same function, and it said, okay, this function is already defined. Okay, let's see. Min 1, 2. It's 1, for example. It's 2, 3, 2. It's 2, okay. It looks good. So this is the term comparison. We could have also some arithmetic expression inside. So let's have a module, for example, greater, and I have module greater exports is greater, and let's just for this say that I will take two arguments. Is sum greater, and it will check if the sum is greater of if the sum of two numbers is greater than some value. So I have when x plus y is greater than 50, return the atom true. Okay, the very artificial example, but just to show that it's possible to also pass to write the expression, which is arithmetic expression within this um, guard, or maybe that the better would be yeah. Let's have a look. So we have Erlang. See. Okay, 10 plus 10 is of course smaller than 50, but let's say 50 and the 1 is of course greater, so we have the true. Okay, so we could also have Boolean expressions like true or false, and this, especially the atom true as a guard, will be very useful for the if expression, which I will be discussing during next lesson. And this if expression, when you are using the true, it will be used for implementing the if else. But I will discuss it in the next lesson. Okay, so maybe last example. Um, it will be related to maybe the true. In this case, I will implement the even module, which will basically return true if the value is even and false otherwise. So it will be something like even x when x rem2 equals 0, then we have true, otherwise we have false. So this will be something like this to check whether the number will be even or odd. So if of course the remainder of division by 2 is 0, then it means it's even, otherwise it's false. Let's see how it will look like. Of course, 1 is odd, and 2 is even, and 3 is odd, and 4 is even, and so on. So this is it. So I really encourage you to go here and read about the guard expression and guard sequence, all of these restrictions related to guards, what can be used there and what not. And that's it for this lesson. Thanks for listening, and stay tuned for the next lesson about the if and case. Cheers, bye bye.